Hello. Uh, Today we extend our existing model of NFA, that is non-deterministic finite automata, to include the transitions without giving any input. That is epsilon. So we consider a transition diagram. Suppose this is Q1, Q2, and Q3. This is the initial state, and by taking 0, then input is epsilon. Again here the input is 1, and here the input is epsilon. Again the input is 0. So it is basically a NFA with epsilon moves, or a finite automata with epsilon moves. Now this epsilon means without reading any symbol. It means without reading any symbol. And in this transition diagram, this NFA will accept a string S, suppose S, if there is some path W from this initial state Q1 to final state Q3. Then we say that this NFA will accept this string S. For example, the string 00110 is accepted by this NFA by the following path. How? Say, suppose you are in Q1, because initial state is Q1. Now after reading 0, you are in state Q1 again, and after reading again 0, you are in Q1 state again. After reading epsilon, you are in state Q2, and in Q2 after reading 1, you are in Q2. Again after reading 1, you are in Q2. Then from Q2 after reading epsilon, you are in Q3, and from Q3 after reading 0, you are in again Q3, and Q3 is the accepting state, so this string will be accepted. So here the input string is, so here the input string is 0 0, then epsilon, then 1 1, again epsilon, and 0, which is nothing but 0 0 1 1 and 0. So one thing, uh, we can go from one state to another state without reading any symbol in this diagram. So adding this facilities basically increases the power of the automata. Now we'll give you the formal definition of NFA with epsilon moves. So the formal definition, NFA with epsilon moves. So a NFA with epsilon moves is defined as 5 tuples. That is Q, sigma, del, Q naught, and F. and all the symbols or all the elements q, delta, sigma, delta, q naught and f, with all the element stated as before, only the difference is basically the delta mapping. This delta is basically different. All the other elements of these five tuples are basically remain the same as we have discussed in the previous lecture. So now this delta can be defined as where it is a q cross sigma, but here another input is epsilon, that means without reading any symbol we can move to any state and it is a subset of q, that is 2 to the power. And the symbol and this symbol sigma union epsilon represents, this basically represents set of input symbol. For example, if we write tell q comma x is equal to some state q dash, here x is a symbol from sigma union epsilon. Now, how do we define the string accepted by this NFA, or a string is accepted? The concept is if we have a path from initial state to some final state. Now, in case of NFA, how we define this? So, for this reason, we need another concept, that is a epsilon closure. So, now we define the epsilon closure epsilon closure. So, epsilon closure of any state or of a state Q is basically is the set of states reachable from Q through epsilon moves, including itself. Including itself. So, this is basically the definition of epsilon closure. Now, if we consider this diagram, Q1, Q2 and Q3, there is some epsilon moves. Now, if we want to find the epsilon closure of these states, so what will be the epsilon closure of Q1, what will be the epsilon closure of Q2, and what will be the epsilon closure of Q3? Now, in this diagram, epsilon closure of Q1, so we define the epsilon closure of Q1 is equal to, what is the definition? Definition means if you want to find epsilon closure of any state, is basically is a set of states that are reachable from that state Q through epsilon moves, including itself. Now, if we want to find the epsilon closure of Q1, that means it basically returns a set of states that are reachable from this Q1 through epsilon moves, including itself. So from Q1, through epsilon moves only, we can reach Q2 and Q3. And lastly, we have to include the state itself. So epsilon closure of Q1 will be Q1, Q2 and the Q3. Similarly, the epsilon closure of Q2 will be, epsilon closure of Q2 means from Q2 through epsilon moves, what are the possible states that you can move? That means Q3 and including itself, that is Q2. So it will be Q2, it will be Q2 and Q3. Similarly, epsilon closure of Q3 will be Q3. So in this way, we can find the epsilon closure. Now, we define the extended transition function with NFA epsilon moves. So, extended transition function or extended delta in NFA epsilon moves. So, we can define, so extended delta to Q cross sigma star to 2 to the power Q. We use notation that is delta star. Suppose the initial stage Q naught epsilon is basically epsilon closure of Q naught. So we just extend this delta. As we have seen, Q cross sigma star to 2 to the power Q. We extend this concept here. So it is delta star Q naught epsilon is basically epsilon closure of Q naught. Now if we have a string, so string WA, we can define delta star Q naught and WA, where W is a string. So we can write epsilon closure union del R comma A, where R belongs to delta star Q naught W. Okay. So this is the definition of extended transition function, that is delta star when there is a NFA with epsilon moves. Now, what is the meaning of this delta star Q naught WA? So, delta star Q naught WA, what is the meaning of this? It means starting from Q naught, starting from Q naught, after reading WA string, what are the possible states that you can move? Clear? So the meaning is simple. Q naught, here Q naught is any state, or may consider that initial state is Q naught. So after reading WA, what are the possible states that you can move? And WA means, suppose you are in Q naught and after reading W, you obtain some states, that is R, and after reading A, what are the possible states that you can move? Now, language accepted by this NFA epsilon moves can be defined as, suppose language L, the machine M, language accepted by this machine M is basically equivalent to, is we can write W, that is string, suppose such that W belongs to sigma star and delta star from Q naught initial state. After processing W, it contains a state from F. So this string accepted by this. So from this example, what is delta? Del Q naught of 0 is basically it will give you the Q naught. Go to this example. Sorry, no, from Q1. But rather we'll take another example. It will be better. We'll take another example. Suppose we have a transition diagram like this. Q naught, by taking 0, you are in Q naught. By taking epsilon moves, you are in Q1. And by taking 1, also you are in Q1. And Q2, by taking epsilons by 2, you are in Q2 states. Right? Now, in this diagram, what is the meaning of del Q naught 0? Basically, del Q naught 0 means if you are in Q naught state after reading 0, what is the state? That is Q naught. But if we write delta star Q naught and 0, it means starting from Q naught after reading 0, what are the possible states that you can move? So it basically defined by using the epsilon closure definition. But now I can write that after reading 0 starting from Q naught, what are the possible states? So you can stay in Q naught after reading 0, or without reading any symbol from Q naught you can go to Q1. Similarly, after reading without reading any symbol, that epsilon means without reading any symbol, you can go move to Q2. So these are the possible states. So this is basically the difference of delta and the extended transition. Now we define, suppose what will be the outcome of delta star Q naught 0 1. What will be this? That means starting from Q naught after reading 0 1, what are the possible states that you can move? Obviously, the answer will be up from Q naught after reading 0, you are in Q naught. Then without reading any symbol, you can move to Q1, where you can exhaust this one. Now you are in Q1. So the possible states are Q1, and without reading from Q1, you may also go to Q2. So Q2, these are the possible states that you can move. Now using this formal notation, how do we get this? Using this formal notation means how? Using this formal notation, how do we get this Q naught, Q1, Q2? So now, formally we can do by using this. Suppose delta star, right? So Q naught 0 1. Basically, we can obtain epsilon closure of union del R comma 1, where R belongs to delta star Q naught and 0. We can find using this. Now, what is delta star Q naught 0? As we have mentioned, this is delta star Q naught 0, the outcome of delta star Q naught 0. Clear? We can also define how we can find this later on, but now uh, what is delta star Q naught 0? Delta star Q naught 0 is basically returns Q naught, Q1, Q2. So we can write epsilon closure of union del r comma 1, where r belongs to Q naught, Q1, Q2, right? Now we can write epsilon closure what we have obtained here, this r will be replaced by Q naught, Q1, Q2. Now we can write del Q naught 1 union del Q1 1 union del Q2 of 1, right? Look here, 1 is the input here, so Q naught, Q1 and Q2. That's why Q naught, Q1 and Q2 and all are union. Now further epsilon closure of, so now go to this diagram. So starting from Q naught after reading 1, starting from Q naught after reading 1, what is the state? No, there is no states. So we can write here, it will be empty. Union from Q1 after reading 1. From Q1 after reading 1, what is the state? That is Q1. So we can write here the Q1 union for Q2 1. From Q2 after reading 1, there is no transition. So we can write here the null or empty. So now actually it gives epsilon closure of Q1. So which is basically epsilon closure of Q1 means, as we have defined, what is the meaning of epsilon closure? Epsilon closure of Q1 means it basically returns set of state that are reachable from this Q1 through epsilon moves, including itself. So by this, from this diagram, epsilon closure of Q1 means what are the states that are reachable from Q1 through epsilon move. That means from Q1 through epsilon moves, we can move to Q2 and including itself, that is Q1. So we can write the outcome will be epsilon closure of Q1 will be Q1 and Q2. Now we give how we find this epsilon closure or delta star Q naught 0 is basically this, right? So now we can define here. So we can write basically what is the meaning of a delta star Q naught epsilon? It basically epsilon closure of Q naught. So what is the meaning of epsilon closure of Q naught? Epsilon closure of Q naught means the state that are reachable from Q naught through epsilon moves, including itself. So it will be Q naught, Q1 and Q2. Right? Now we can write delta star Q naught 0 means we can write epsilon and 0. So this can be written as epsilon closure of union del r comma 0, and r belongs to delta star Q naught epsilon. So it basically, this basically returns Q naught, Q1 and Q2. So epsilon closure we can write del Q naught 0 union del Q1 0 union del Q2 0. So what will be the outcome? From Q naught after reading 0, so it will give you the outcome Q naught. From Q1 after reading 0, there is no transition, so it will give you the empty. From Q2 after reading 0, what is the state? That it will also give you null. So basically we obtain epsilon closure of basically Q naught. So Q naught, as the outcome will be Q naught, Q1 and Q2. So in this way we can calculate the epsilon closure of any state. Now equivalence of NFA with epsilon moves and NFA without epsilon moves. So equivalence of NFA with epsilon moves and NFA without epsilon moves. So we assume let M equal to Q sigma del Q naught and F be a NFA with epsilon moves. And then NFA without epsilon moves, we assume that it is M dash, can be constructed. This M dash is basically NFA without epsilon. So NFA without epsilon moves. We have to construct this M dash such that language accepted by this machine M, that is NFA with epsilon moves, also language accepted by the machine M dash. So same language are accepted by both of the machine. So we are basically trying to remove these epsilon transitions without changing the language. Clear? So what we are trying, so we are basically trying to remove the epsilon moves without changing the language. Now M dash will be, so M dash is defined, M dash means NFA without epsilon moves, as M dash is equal to Q sigma delta Q naught and F. Here only two things will be changed, transition and the final state. So these two things will be changed. Here it will be changed and this will be changed, and all other will remain same. Now what will be F, or simply F dash? F dash will be F, that means the final state in NFA without epsilon moves will remain same with the NFA with epsilon moves if epsilon closure of the initial state, that is Q naught, does not contain a state from F. Otherwise, it will be F union Q naught. When if epsilon closure of Q naught contains a state, contains is epsilon closure of Q naught contains a final state, contains a uh, contains a state from F. That means final state. So NFA with epsilon transition, epsilon can be accepted if epsilon closure of Q naught contains a state from the final state. And one thing noted, if the initial state is a final state, then the machine can accept epsilon. That's why this concept. Now, how we define this delta dash? So delta dash can be defined as suppose you are in Q states and input string is A. So we can write it is basically or we can add here basically the delta star Q, or can write in that way. So it is basically equivalent to epsilon closure of union del R comma A, and R belongs to delta star Q comma epsilon. We can write in that way. So we have to define delta dash in this way. Now we'll give an example, a complete example. Suppose we have a NFA transition diagram with epsilon. So the previous example, we can also discuss the previous example where it is a Q naught 0 epsilon Q1 1 epsilon Q naught 2. Okay, we can we design again this transition diagram. So it is basically Q naught, then Q1, then it is Q2, and epsilon transition, and it is the initial state, it is 0, it is 1, and it is basically a 2. You can write it is 2. Okay, now we have to remove this epsilon from this transition diagram. Now as we have seen that this NFA can accept this epsilon, because without reading in any symbol we can move to Q2 states, right? So as epsilon is accepted by this diagram, so we have to make this initial state, that is Q naught, as a final state. Later on we discuss how. Now steps are basically, we have to consider, just we have discussed here, A is basically a symbol, and for all the symbols A we have to find these transitions. for all the symbols. Clear? So how we can construct this? We can construct by using these concepts. So A here is a symbol for all the symbols. For all A belongs to sigma, we have to do this. Now, so first is Q naught, right? So from Q naught, we have to find this. What is we can do this by epsilon close delta star from Q naught by taking 0. What are the possible states that we can move? So we can find by using this epsilon closure of, it is basically a Q naught. Why it is epsilon closure of Q naught? We have already discussed this. Again, we can do this. So delta star Q naught 0 is basically, we can write in that way, delta star Q naught epsilon 0, which is basically we can write epsilon closure. We can write epsilon closure of union del r comma 0, and r belongs to delta star Q naught and epsilon, right? So now what is delta star Q naught epsilon? So delta star Q naught epsilon means starting from Q naught after reading what are the epsilon closure of Q naught means? Epsilon means it basically gives you the epsilon closure of Q naught. So it basically gives you the epsilon closure of Q naught from this definition. Look, delta star Q naught epsilon means epsilon closure of Q naught, right? So from this definition, we can write that it is basically the epsilon closure of Q naught. So epsilon closure of Q naught means from this diagram, we can find that the states that are reachable from Q naught through epsilon moves is Q1, Q2, and including itself, that is Q naught. So it basically gives you the output Q naught, Q1, and Q2, right? So this epsilon closure, so after doing this, so basically, so again, we further do some steps. Closure. So we can write del Q naught comma 0 union del Q1 comma 0 union del Q2 comma 0. So now this Q naught 0 will give states Q naught. So it will give you the Q naught. So Q1 0, no. So it will give you the null, and Q2 0 will also give you null. So now basically it is epsilon closure of Q naught. That's why I have written here epsilon closure of Q naught. So which basically equals to Q naught, Q1, and Q2. Right? Now delta star Q naught 1. It basically gives, so from Q naught after reading 1. So from Q naught, without reading epsilon, we can go to Q1. Clear? And in Q1, we can exhaust this one. Clear? So now what are the possible states that you can move? So after reading, so we can write in that way, just epsilon is before the 1. So through epsilon moves, we can go to Q1. So one of the state will be Q1 and another state will be Q2. So which is basically nothing, the epsilon closure of Q1. So it will be basically Q1 and Q2. How we construct this? Again, Again, we can do this. How? Look, uh, delta star q naught 1 is equal to epsilon closure of union del r comma 1 r belongs to delta star q naught basically epsilon, because we can consider that there is an epsilon here. In that we can do this. So now it basically epsilon closure. So delta star q naught epsilon means here q naught, q1 and q2. So we can write del q naught 1 union del q1 1 union del q2 1. So it basically gives you, so this basically gives you q naught 1, it will gives you the null, q1 1 gives you q1 and q2 1 basically gives you null. So that's why I have written here the epsilon closure of q1. So it basically gives you epsilon closure of q1. So which is nothing but q1 and q2. So we have obtained q naught 1 0 and q naught 1, and also we have to consider delta star q naught 2 also we have to consider for all inputs, as we have mentioned here that for all input we have to do this. So here the input symbols are basically 0 1 and 2. Here the input symbol 0 1 and 2. So for all the symbols 0 and 1 we have done. Now we have to perform for 2. So we can write it will be epsilon closure or union del r comma 2, where r belongs to delta star q naught epsilon, and this will give you q naught q1 q2. So simply we can write epsilon closure of del q naught 2 union del q naught 1 union del q naught 2, right? Now it will be q naught 2 basically empty. Oh, sorry, it will be 2. Q naught, sorry, it will be 1, not q2. I've done wrong. It will be q1, it will be q2. So now from q naught by taking 2, no, from q1 by taking 2, it will also gives empty, and from q2 it will basically give you the q2. So basically it gives epsilon closure of q2. So it means it basically returns a q2. Clear? So we have obtained for all the states we have to do. Now for q naught we have done for 0, 1 and 2 all the symbols covered. Now step 2. Step 1 we have done. Now step 2 we have to do for q1. Now we have to calculate for delta star for q1 0. Similarly we have to calculate delta star, same procedure we have to follow, q1 1 and delta star q1 2. We have to do this again for all. So now if we do this, we will obtain the result. It will give you the empty, it will give you q1 q2 and it will give you the q2 only. Clear? Now one we can do on steps. Suppose no, not necessary, we can later on can check. Now we have to do for delta star same concept for q2 0. Similarly for delta star Q2 1 and delta star, sorry, Q2 2. We have to do this. And again we will obtain, it will null, it will also give you the null, and it will also give Q2. So all the states with their corresponding input symbol we have covered. Now we have to draw the, so transition functions we have defined. Now we have to draw the transition diagram by using this. Now go to these steps first. From Q0, by taking 0, what are the states that you can move? Q0, Q1 and Q2. So now we draw the diagram, transition diagram. So it will be Q0, it will be Q1, and it will be Q2. Right? Now, as before, we have seen that it is a final state and it is the initial state. So from Q0, by taking 0, you can move Q0, Q1 and Q2. So we can write, we can move Q0, we can move Q1, we can move Q2. Right? Similarly, from Q0, by taking on, you can move Q1, Q2. So we can write here, comma 1, you can move Q1. From Q0, by taking 1, you can move also Q2. Now last 2, Q0, okay, Q0 2, we can move only Q2. So we can write here that by taking 2, we can move Q2. So we have done step 1. Now step 2. Here, from Q1 state, by taking 0, no transitions. From Q1, by taking 1, you can move Q1, Q2. From Q1, by taking 1. From Q1, by taking 1, you can move Q1 as well as Q2. Right? So step 2, another Q, from Q1, by taking 2, you can move Q2. So we can also write here the 2. Now from state Q2, by taking 0, no. From Q2, by taking 1, no transition. From Q2, by taking 2, only Q2. So we can write here as look, it will be 2. So now this is a NFA without epsilon moves. Right? Now what will be the transition we have done? Now what will be the final state? As we have defined, in case of construction, this NFA without epsilon moves, this F dash final states will be only if epsilon closure of Q0 does not contain a state from it. That means does not contain a final state. Otherwise, it will be the final states will be whatever in the NFA with epsilon moves, including Q0. That means epsilon will be accepted. String of length will be accepted. In this scenario, Q0 will be the final state also. So now, what we have obtained in case of epsilon closure of Q0? Oh, obviously we can define here. What is the meaning of this epsilon closure of Q0 here? Or what will be the outcome of epsilon closure of Q0? Here the outcome of epsilon closure will be epsilon closure of Q0 will be Q0, Q1 and Q2. What we obtain? So that means as epsilon closure of Q0 contains a state from F, that is this is F final state, And this final state is a transition diagram where epsilon present. That means NFA with epsilon transitions. So if we find epsilon closure of Q naught where contains a final state, then it will go to this definition. It will go second. That means it satisfies the second, right? F union Q naught. So in this transition diagram, as epsilon closure of Q naught contains a state from F, so F dash is basically F union Q naught. So basically it will be Q naught and Q2 both will be the final states. That's why we have to make this state also the final state. It means this NFA, so it means this NFA will accept epsilon. So now it is a complete NFA without epsilon moves. So thank you for today's lecture.